it should be another draft physics video presentation. Start with comments and I'll move along to maybe a couple of other things, just re-emphasizing points, trying to make it clearer, maybe. I already think I made it pretty clear, but you always can make it clearer, so I'll attempt to improve on or re-emphasize the obvious, what I've made obvious. You know, obviously it wasn't obvious to me, or I would have made this video 10 years ago. So unfortunately it took a while to deconstruct all the bullshit. So anyway, let's see which one to do first. I guess I'll do the top one first, top down. It's only a couple of jerky comments. So this Paul Francis, who left some other comment I didn't bother reading because it was sort of whatever, fluffy. I like hearing about some of the comments and your comments. And then he posts kind of a snarky pile of shit comment. You've never heard of broadband receivers? Get your ham license. No, I wouldn't bother doing that, frankly. It's not really an elemental physics kind of license. But anyway, so I guess this is in the context of understanding jamming and understanding how we would detect microwaves. And but the simple argument I can draw, the simple argument is we're talking about a phase difference and whether you could detect a phase difference. Now when they do the radar experiment, they always, just about always, essentially always, or the radar experiment. Now, once in a while they do make physical slits, okay? There are some people that make physical slits to send the radar through, okay, to actually create a duplicate of the two-slit experiment, but most of the time it's just, they just create two radar sources, okay? They're tied together, so they are creating radar in phase, technically, possibly. Anyway, the whole question is we're still arguing about phase differences and how they're detected. Now, the point I've made is that we can't receive signals, okay, from things that are out of phase. If two signals come in and the two signals have the same frequency but they're out of phase, okay, we don't have a receiver that can decipher that, okay, unless it's directional. So unless the two are coming from different directions and we can turn an antenna and try to figure out which one we want to try to capture, the receiver would be disabled, in terms of if I just have a straight antenna and I put two signals of the same strength at the same frequency out of phase, it can't see either one of them. It can't focus on either one of them. All right, so the information is not accessible. It has to be in phase, or else the radio is jammed. And it doesn't matter, broadband, all this other stuff, it doesn't make any difference. It can't do it if they're out of phase. So they have to be in phase to be received, to be constructive to each other. And then the question becomes what amplitude they have, what signal is on top of them can be, seen, as long as their phase is in phase and they're at the same time for you to get the same sound. Now, obviously, if you're out of phase in terms of the signal that's carried, then the signal will be destroyed and you won't hear it. So there's another reason why you might not hear a signal if you're using a tone on the instrument itself. Now, the other thing you can kind of understand, obviously, is that, we can collect a group of FM radio, collects a group of frequencies, okay? So these are all subtly off. This is 230 megahertz, and this is 231, and this one's, and so it's using a whole band of frequencies to carry the information. So in a sense, FM is broadband, okay, and you can have even broader band, but the problem is you can't have broad enough band to see what the thing you're trying to see is which, when I combine two out of phase signals, I'm actually creating a frequency that's double. When they're perfectly out of phase, these two signals end up creating a signal that is twice the frequency. And we don't have broadband that can do that. So, and certainly not capable of deciphering any information that would be on the signal. It could create, it could detect it as raw energy, but it can't detect it and decipher any information that was on this carrier or that carrier. It couldn't deconstruct it and find out what information is on that carrier. So all the carried information would be lost. So obviously if you're dependent on hearing a tone, even if you detected the signal, you're not going to hear the tone. So that won't work. That's why. So I don't need a license, okay? I don't need a fucking ham radio license to understand the implication. The simple argument is that it's double the frequency. So show me your broadband radio receiver that can handle two frequencies that are double each other. 10 gigahertz and 20 gigahertz. And it can detect both signals at the same time. Yeah, go ahead, show me that one. Or otherwise, just shut the fuck up. Yeah, this nasty little creep. So we'll remove that one. We won't block him yet, but he's pretty close to being an arrogant fuck. Anyway, I mean, it's just obnoxious. You can't just raise your... Well, I don't know. That doesn't quite make sense to me. What about broadband receivers? Couldn't they just broadband receive the signal and detect both the 10 gigahertz and the 20 gigahertz signal? You could say something like that. But you didn't. You chose to be a snarky fuck. Excuse my French. Anyway, I have a question. If four people are standing at the four vortices of a square, now you couldn't just say corners, right? So this is more just, you're just a horse shitter, when you have to use the word vortices to describe the corner of a fucking square. Anyway, then how can A and D and B and C as the light, the electric magnetic field? Well, I've obviously stated I don't believe in this stupid field crap. Shit. Crosses at the center of the square. So again, there's not a single experiment, okay, outside of gravitational lensing, okay, which I'm saying is a fraud, and, Einstein spent photons in gravity. Outside of that, there's absolutely zero evidence that you can ever bang a force into another force, okay? There's just not a single experiment. We can't shoot light beams at light beams and make the light fly all over the place, right? If I shoot two lasers at each other, I'm not going to see an explosion of light flying in all kinds of pieces. I'm not going to deter this beam, and I'm not going to deter that beam, and I'm not going to change a damn thing. And no matter what force we try to throw at another force, anything moving the speed of light, we crash it into something moving the speed of light, we don't get anything. Alright? Unless it's matter. The forces don't do it. X-rays don't do it. Microwaves don't do it. Radio waves don't do it. None of them, okay, show any evidence that they have any interest in banging into each other. Okay? Ever. Ever, 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 ever. So your premise that this is some sort of dilemma, that you have your little stupid square and that somehow this energy is going to crash into this energy and they won't get any energy. No. And the simple logic is, I could say they just go right through each other. I could say they just miss each other by the rules of the universe. Or I could say, yes, they crash right into each other and they reflect off of each other. And what is the outcome? Well, if they miss each other, the universe will look like this, right? One thing will be going this way and one thing will be going that way. And if they hit each other and reflect, the universe will look like this. One thing will be going this way and one thing will be going this way. You can't tell the difference, equal sign and such, between the two universes. So nothing can possibly change when they hit each other, and it's a purely kinetic interaction, and all of the energy is just transferred. So this one's going this way and this one's going this way. And this one will go this way, and this one will go that way, because they will just exchange identity. That's it. So you end up with exactly the same universe, okay? So the rule can be they never hit each other, or the rule can be is, yeah, they hit each other all the time, but it doesn't matter because they just create the same outcome in that individual interaction. You will be able not to be able to detect that anything changed at all because they hit each other. So, I mean, I have been over this and over this and over this and over this, but whatever. people don't care to look very deeply, so we have to keep doing the same crap over and over again. So anyway, I've responded to your comment. It gets 2 thumbs up for this piece of shit. I mean, it really has been gone over 100 times in these videos, at least 100, more than that. I've drawn that simple. I've made that simple statement at least 100 times. And yet 2 thumbs up for that pile of shit. Alright, so just remove it. Garbage. Try again. Dumbass. Alright, so that's the comments. Alright, so let's go to, since I have it here anyway, Professor Lewin again. So I'm going to re-emphasize some of these points about two-slit, because that's the subject I'm going to be able to debate on mostly. I'm going to try to make it ray versus wave conversation, you know, broaden the conversation in the debate to the whole concept of light as some sort of wave and some sort of mediums, some sort of fields, which is just poo. It's just so bad as an explanation. And you can see it in their own deceptions and frauds and phoniness. So here, you know, this is, you can see the background, right? Right here in the image, you can see this background. You can see where he drew these waves. The centers are in the center here and here. That's not where the math says the centers are. The centers for the math are here and here. So completely different place. Brief pause and such. Anyway, so you can see in the drawing, okay, this is red line is around the 2 slits, blah, blah, blah. He shows this, the openings as being the centers. I mean, clearly not the number he's going to put in the math. The math is not going to have that center as the number. It's going to have the width of the slit, because he's going to assume that the openings are so small that he can use the same number. So, you know, the cheat is just so obvious. You know, and then here we'll play him looking at the actual outcome of the experiment, and in a sense just mocking any notion of serious science.
And turn off the lights. Make sure I have mine. Okay. And there you see it. There you see.
Not quite.
A maximum darkness. A maximum darkness. A maximum darkness, and so on.
So there he actually does have the, you know, it's obviously a very small slit because you only have 3 nodes inside of the envelope. But clearly, I mean, it's just gigantic gaps just sitting there looking at you, and he just goes, light, dark, light, dark, light, dark, light, dark. There's nothing to explain here. There's nothing, no aberrant event at all. Nothing to notice. Don't pay any attention to that bizarre change in the pattern. That missing node. Okay. Yeah, so, you know, I mean, how obvious does it have to be that they're clearly forcing their theory to work? It doesn't work. It doesn't explain the reality at all. And they're just forcing it to. Okay? And they're just forcing it by ignoring it when it's right there in front of them. It's glaringly staring them right in the face, and they just walk right past that truth. All right, let's see what else he says.
And the separation, if I didn't make a mistake, between the maxima is indeed about 7 centimeters.
Well, we know that can't be right because we know there's a missing one right here. So, well, that's not going to work. Right? Duh.
Imagine what an incredible moment this is in your life. That you actually see that light plus light can make darkness.
So that's what he's claiming, but there's no such thing. There's no such light plus light equals darkness. That isn't proven by this image anywhere. There's no evidence of that. That's just what they believe, because these things get brighter when they close one of the slits, right? It'll get 4 times dimmer. So because the bright spots get 4 times dimmer when you close one of the slits, you know, and therefore if we open the slit, they're arguing that somehow this place would have been light and now it goes dark. They don't have any evidence of that. They don't have an experiment that actually demonstrates that, where light goes away.
Waves go simultaneously through both openings.
So again, it's 2 waves. Now, the math that actually describes that real pattern has 4 sources. Okay, so if you're going to call them waves, you'd have to make 4 waves. All right, so he just says 2 waves like it's the Young experiment, like it's 200 years ago, and we don't know this is the real pattern. That you have to explain these dark spots. That there's 2 patterns here.
And each opening acts like a Huygens source. And the net result is...
So more stuff, we'll go back to the 1600s and accept a theory that was, contrived to explain. And it didn't work that well. I mean, it didn't convince Newton. Huygens had his chance, and Newton wasn't all that impressed.
That these 2 waves arrive there on the screen, 180 degrees out of phase, at the locations of darkness. The censor is, of course, that...
Right. Well, that is true. So the dark spots do represent, where the photons are out of phase. But clearly the dark spots aren't very dark spots here, are they? Yeah, there's a big pile of light bleeding between these, isn't there? Yes, there is.
They have exactly the same frequency, which is what they do, because we have one laser gun going in, and so the wave goes through both slots. So we're guaranteed, and that was the secret that Young understood, you guaranteed.
So more Young understood when Young didn't understand these dark spots. If Young knew these dark spots existed, maybe he did, maybe he was just saying, I'm going to pretend they don't exist. But they're clearly there, and they're clearly not explained by a 2-wave theory. A 2-wave theory doesn't work.
That the waves are not only the same frequency, but they're even in phase, because they both go through to both slots. Now, if you look very carefully here, you will see, of course, that these maxima don't have the same strength.
So it's surprising that, these students are all sitting here looking at this, and they're just, it doesn't occur to them to ask the question, well, what about those dark spots there? What the hell are they about?
We will understand next lecture why that's the case. They would have very closely the same strength if the opening, where we scratched out the black on the slide, was much, much smaller than the separation between the 2 slots, so to speak. And that separation is 0.088 millimeter. If we make the openings much narrower, indeed, the light intensities would be more uniform. Each maximum would be approximately the same strength, but then very little light will go through, and so it's a trade-off. And the moment you make these 2...
you'll eliminate the 2 pattern part too. So you'll get rid of this empty spot here, but you'll just get rid of these blobs, and you'll end up with essentially 2 single-slit experiments. That's when you end up with 2 single-slit experiments, except because it would just be a big blob here and then smaller blobs going on.
Openings, these 2 slots.
But again, he doesn't say anything about, well, we really should be projecting this on a curved surface, on a circle, an equidistant. We should view this stuff from an equal distance to see it the way it actually is, how it's actually flying through space.
Larger and larger, you will understand Friday why then the light intensities are not the same, why the light intensity...
So the big, huge reality is the math will not predict this flat surface. They don't have anything in the math to tell them that these dark spots will get bigger and bigger and bigger. Everything's stretching as it goes out flat on a flat surface. There's just no attention paid to any of the optics that are a real part of this.
There is a maximum at the center and then falls off near the edge. As you see, it's a maximum here and then the light...
Right. I mean, you can even see a little dot way out here, I mean, just know who cares, okay? Who cares about the real facts, the real experiment? What you got is real data. Who cares about that? That isn't important. The real data isn't important. The real... what the experiment actually does, it's just how much of it can I turn into, well, it's a dot, that's wave interference automatically when you have on-off pattern. Doesn't matter, the pattern's broken, who cares? It's on-off interference.
Intensities become smaller.
Alright, so there you see the illustration. 2 waves, doesn't work, doesn't really explain the pattern, and the simple formula is just going to be this. He has the L number. The D number is the distance of the surfaces, and he's only using those surfaces for his purpose. Like I say, if you use the distance from the 2 outside of the slits, you get a different number.
I've shown you now.
Okay. So he uses a comparison between. Well, here he has the formulas written down, so that's all you need. So it's just this L is the distance to the target times lambda, right, divided by D. And D is the distance between the two slits. And obviously the further out they can make that, they can get a better approximation, right? So if they actually did use the two wave sources as the D, but they don't do that. But if they bothered to, then they get even a better number. So again, let's just point it out again, all right? Well, let's point it out with the single slit first. So the single slit math is that same math. L times lambda divided by D. And D is this distance, okay? So when they do the math, they're using this as the distance between the slits. This distance from this point to this point. Now, obviously, they're going to do the same wave interference. That is, they have to create two waves. Well, they don't put the two waves here and here, right? That would be the rational thing. You're saying that there's somehow two waves created. They go through space, they interfere with each other and create the pattern. Now, the first problem they have is the pattern isn't, even in the single slit, the pattern is eccentric to their math. Okay, it's doing something their math doesn't predict. Okay, so let's understand it's doing this. They can't draw you two waves that do this. Okay, this big thing in the middle, there's no explanation in their theory. Nothing. They have no explanation for that. Two waves can't do this thing in the middle. So they're already in trouble because, yeah, that doesn't work. Then they're in trouble because the distances here would be 1/2 D, right? If these were the 2 point sources, as if this is where the waves are, right? We're saying that the wave is going out, which you can describe a wave, a spherical wave. You can describe it as just a point source, okay, that pushes out in all these directions, right? And we're just talking about the directions the two waves go and where they intersect and where they don't, you know, where they meet as peaks and where they meet as troughs will be decided by this length difference in these lines at different points. And so you put a surface here in, and that decides at what places will they be in phase or be out of phase. And so that's all there is to their model. So their model, they draw it one way, right, if they ever draw it. Like I say, they don't like to do this even for the single slit, but that's what they're doing. That's what the math is doing. The math is saying these are the 2 point sources. So their own math is basically saying that and that is the wave. I didn't draw those very proportionally, but you'll get over it. So that's what, these are the 2 waves. Their math is saying the wave is coming from here, and the wave is coming from here. So their math, even if they were to draw the 2 waves inside here, which would be sort of fibbing, how do you make that make sense? There's no young drawing of that. There's no idea that the wave somehow goes halfway over the surface and only halfway into the opening. What wave could possibly create that? How do you make that make any sense? That can't make any sense to anybody. There's no way to do that physically. Physically, a wave can't do that. So, you know, again, I'd argue the obvious conclusion is that this is a surface phenomenon. The surfaces are causing this. This isn't about some wave centered here. It's about a surface centered here. And the surface is what's causing the deflection of the light in all of these directions. And it's just that. The light is just scattering. And you can constructively put a photon back together or not. The photon bits go to all these locations. And so we're back to the bit argument about what a photon is, but I don't know if I want to go there in this video. All right, so let's just do the 2-slit. So we just saw the image of it, right? You saw the image, right? There's no disputing it, right? And you saw his drawing of 2 waves coming out of the slits, right? So this is what he drew, all right, with these as the point sources. Now, obviously, that's a little better than having this as the point source, because the bars you're going to see, those little lights, the actual math that works, okay, the math that is a little more complicated, front and hover or whatever, has 4 point sources. So again, at the surfaces. So I shouldn't really have to go over that. But you saw what he did. He made 2 waves and did this crap. Okay, as if 2 waves could explain the pattern he got, which was this. This is the pattern he got, right? All right, you know, it might have been this, if we could see more of it, and then this. That's the pattern. All right, this 2 waves won't create that pattern. Can't do it. And these points aren't going to create this size. This won't be accurate. So if you want to get this size accurate, the distance from the center of this one and the center of this one, you want to get that right, these are the 2 points you have to use as the distance. And if you want to get this envelope right, you use these 2 points. So these 2 points describe this clump, right? The size of these collected nodes. And these 2 wide points decide the size of this. And it really just has to do with how many wavelengths there are in this distance. And that answers the question. How many of those little lambda things, right? How many of those fit inside here will tell you exactly how many places there can be in phase landings. So it tells you exactly how many sine thetas there are, and for one side, so you just multiply it by 2. So you take the number of lambdas that fit in the distance times 2, and that'll tell you exactly how many you'll have over this 180 degrees. This is a decisive proof. I mean, I don't know what else do you need. I'm showing you the fraud. I'm showing you how it's not correct. I'm showing you that, you know, it's obvious that waves aren't the answer. Waves don't do this, okay? The waves aren't going to be here and then be here, halfway on this slit, and then here, and then here. That's not the drawing. That's not the Young drawing for waves. But that's the model that actually creates the pattern. These point sources create the pattern. Not these point sources. Okay, or these point sources, however you want me to draw that. I mean, you saw it in the video, right? Is there more to say? I mean, every single lecturer does the same thing he just did, where he sits there and just looks at the 2-slit pattern and ignores the fact that it's not a simple on-off pattern. There's more than one pattern in the pattern. You saw him ignore it. It's overt and real, and he ignored it because he doesn't have an explanation for it. You get it? And his drawing won't. He can't draw it and show you how it works because where he's putting the waves can't produce the right answer. It's clearly wrong. And why are you defending it? It's outrageously wrong. I mean, it's catastrophically wrong. Can't you admit that? It's not wrong like, oh, he's just generalizing for the fun of it, to make it simpler. So his lecture's only 44 minutes instead of 47 minutes. I mean, there's no rational excuse for an MIT professor to just ignore the fact that his experimental result isn't what he's claiming it is in his mathematics and his drawing. Come on. There's no reason for that except, hey, he's just forcing it to fit. He's putting a square peg in a round hole right in front of you, and you're sitting there saying that's good science. Good science is if it doesn't quite fit, just hammer it in. You know, let's force it to fit. Let's force the theory to be correct because we want to believe in our woo. And that's all this is. All right. And then, you know, so then let's get to the more obvious, just the stuff that makes this whole thing ludicrous. You know, makes their theory just, what are you talking about? How can this possibly be? So I've pointed this out before, but light polarization, they have no explanation for it. All right, so you'll not find a video from a physics lecturer that will ever go into the simple question, okay, how does this thing, all right, this whatever it is, okay, what is this? How much of this is a photon? Is this a photon? This is all I need and I have a photon? Or do I need this much of it? How much does this thing, how much of this thing do I need before I have a photon? They ignore the question. Okay, fundamental question, right? Really fundamentally important. If you're going to call something a photon, don't you have to give it some sort of dimension? And then we know that this dimension is absolutely huge. Okay, that whatever this is, this field perturbation, this electric field oscillation, well, the oscillation in the electric field is absolutely huge. 2,000 atoms worth. Okay, very, very large. You know, for red light, let's say. You know, green light would be, 1,000 atoms worth. Huge. And we're supposed to believe by their theory that something as tiny as an electron, which is, 1,000,000 times, maybe more, 1,000,000 times smaller than this wave, this oscillation. And we're saying that somehow this oscillation knows to hit just this one little tiny electron. It doesn't hit any other electron, just this one electron. And, okay, that's 1,000,000 times smaller than the wave. And it doesn't touch all the other billions of electrons that are in the same space as that wave. So in the space of this wave, there are 1 billion electrons, probably more, but it doesn't matter. Okay, and somehow it just bothers one, only one electron. And it goes in and somehow the one electron reflects the thing back, this gigantic thing. The one electron does that. Now, you know that doesn't make any sense, right? You can figure this out. Okay, so let's understand the two-slit experiment in that context. That we know the two-slit experiment, it's really important how many wavelengths, right? How many wavelengths of light are in between the two slits. So that's, even they sort of know that's sort of important. How many wavelengths you have in here. How many would fit in this distance? And again, it turns out to be exactly you could just draw the line for the wavelengths. You could just go like this, okay, and you could just draw them for this one side like that, and you would have the right answer. That would be your interference. So it's that proportional. Exactly how many wavelengths you have in here will decide how many places you have where the wavelengths are equal. They're in phase. So in phase, the numbers are exactly identical for the one side, like I said. So obviously you just have to expand that to say there's twice as many. So you just have to do 2x, because you gotta go this way too. But that's it. And where was I? All right, so we know wavelength is critically important, and we know wavelength is the same, the distance between these nodes, these waves, is the same as this polarization distance. So it's, in the case of red light, it's something like 2,000 atoms worth. There's 2,000 atoms worth of distance, okay? 500 nanometers would be about 2,000 atoms. Maybe less, maybe a little more. So same difference. 1,000, 1,500, something depends on the material, right? How many atoms it's going to be. But anyway, at least 1,000. We can just say that. So it's 1,000 atoms worth of distance between the nodes of the wave and the thickness, the height, the amplitude, whatever you want to call it, of the field change. So the field is a big part of space is being affected by this field change, this electric field change. All right, so we have this tiny thing, an electron. So if, let's say we want to make a proportional experiment. We want to make a two-slit experiment for an electron, right? Electron doesn't have this. stuff. It doesn't, it doesn't have any of these features fundamentally. No, the electron is just a tiny thing, and we know that it's a tiny thing because we know how hard it is to hit one. You have to go into a few atoms before you'll start hitting the electrons because they're sparse and small, so they're not that easy to hit. All right, so it's a very, very small thing. A million times, again, it's more than that, but I could say a million times smaller than one atom. Just one single atom is, this is 1,000 atoms. An electron is a million times smaller than the whole size of the structure of the atom. And so we know that there's only a tiny number of these little thingies, wavelengths inside, a very finite number in the double slit experiment with light. It's not a zillion of them. But we know, that even if I made really small slits, like 1 nanometer slit, I made a 1 nanometer slit. I mean, it's an incredibly small slit. I mean, too preposterously small for me to even describe how small that is. It's still gigantic compared to the size of the electron. So you still have a gigantic number of electrons that would fit inside of there. That would represent its polarization or its wavelength. A gigantic number. And then the fact is the electron we know is charged. So how do I make two slits that don't have any charge potential on them? None whatsoever. There's no electrons on the outside of the atoms on this surface. No electrons on the outside of the atoms on this surface. Where am I going to make that material out of? So we know there's something fundamentally wrong, okay, with this idea of the electron experiment, the electron two-slit. That this is obviously some kind of very complex thing that they created, or some kind of it's just a totally misinterpreted pile of mush. I mean, what they're detecting are X-rays that go in with the electron. Electrons are pushed, okay, by energy. That's how you make electrons move, is you push them with energy. And the truth is there's a whole bunch of energy going with the electrons. And they get, and that's what you can see the pattern of. Because how you detect electrons is basically not very different from how you would detect X-rays or some other high piece of energy, photon. The same things that will be affected by an electron hitting it at high velocity are going to be affected by photons hitting with a high frequency. So your detection gets a little more complicated when you're detecting electrons. Now what you could do is put a screen up, right? So like a microwave oven, you can create a bunch of little holes or some other kind of a thing that'll block the X-rays, in a sense, break some of them, so less of them get through here. They're little pieces of photon rather than big pieces of photon. So they go from being this long to being this long, and all of a sudden now they can't be detected because they don't produce enough energy continuously. It's too short a pulse to have the same effect that creates electricity. See, and again, we detect everything almost based on the fact that it has to create an electric current. It has to move electrons through a wire for us to detect it. So there's lots of limitations to our vision. And again, you could put a magnet here. I said this before. I could put a magnet here, and I can push the electrons this way, okay? And that way the X-rays will still go this way, but the electrons will go this way. So I can crash the electrons into a surface over here, and I'll see just the electrons then, because the X-rays won't go with it. So there's ways of doing it, but there's obviously, it's a little bit complicated to say, okay, I shot electrons, and none of the X-rays affected my results. None of the energy pushing the electrons, whether it's ultraviolet or infrared or whatever it would be. The energy pushing the electrons, okay, ends up coming to the surface. Now, the reason why, like on a TV screen, it doesn't get to you is there is a screen for the TV. And the screen for the TV is like a bunch of holes, and it's like a microwave oven. It breaks so many of the photons. The microwave photons get broken going through the hole because their polarization is bigger than the hole. See, the whole way you can neuter a photon is to create a hole that's smaller than its polarization. So if I, I mean bigger, smaller, yeah. So the holes in a microwave, like the door, are like a millimeter or whatever, a little more, 2 millimeters maybe, something like that. Doesn't really matter. And the polarization is like 3 centimeters. So the holes are much smaller than the polarization of the light. So each hole is fragmenting the pieces of the microwaves, and so it's dulling their capacity to recombine in some location, because you're breaking them into so many different pieces. Oh, shit. Shit happens, as they say. Into every life, some shit must fall, and all that kind of crap. Anyway, so that's the principle, right? So, a TV screen obviously has the phosphorus and has a screen and has different layers of crap, and that crap is what's basically blocking all of the high energy X-rays and such that would have been coming out of the TV if it didn't have those mechanisms. The glass itself is a problem, for the different frequencies, to be able to transmit through it. Glass is opaque to high frequencies. So, lots of ways that they could eliminate the problem of the real pushing energy being visible or effective. Like I say, you're just basically saying, look, I'm going to turn a wave array this long into an array this long, and these little little pieces here, little piece here, little piece here, and those little pieces don't add up to this continuous piece. This continuous piece can create electric current. These little pieces can't, and that's a big difference. Yeah, that's probably enough of that. It's it's all a little bit nuanced. Nobody wants to pay attention, like the message boards and what's always the evidence. It just doesn't matter. People don't want to think about these questions because it's a little bit of a nuance. You have to go through some of this stuff and talk about the different experiments and what they produce as an outcome and what can be deduced. And they just say it's all been done. And what I'm saying is clearly I can show you how it hasn't been done right. It's been done wrong. It's been done quote mining the outcome of the evidence, saying that I'm going to show you certain pictures. And he had to show the double slit. And even when he showed it, okay, just recognize, even when he showed it, he refused to describe it accurately because he can't. He can't explain what really happens.
You see, a maximum, darkness, a maximum, darkness, a maximum, darkness, and so on. And so, like, again, it's overt, right in front of your face, something that simple. And he had to, what? It's something other than kind of lie about it, like he doesn't see it himself. He doesn't know that weird little dark spot is there. Of course he knows it's there, but he's saying it's too important to preserve Huygens and wave theory for me to have to deal with that truth, because that truth does have an explanation, and the explanation is incompatible with wave theory because the waves are in the wrong places, completely wrong places. And it's perfectly consistent with particle scattering theory. Particles scattering explain that. Waves don't. Shit. I mean, again, how you're just demonstrating just how little integrity people have. That I can make these videos, get, say, 300 views, which maybe you could say 90 people. I don't know. 90 real people or 90 something. You could just say that many people. And they can't just concede, yeah, that looks pretty bad. That's pretty bad description of evidence. It's a pretty bad explanation. It's really poor. It's not very scientific. It's not that whole idea of, finding the truth and caring about the truth and all of this, repeating the experiments. And they don't, why do they need to repeat it when they can just overtly mischaracterize it, right? Is that what, I'm not going to say lie, right? Because lie is too strong a word. But I mean, the mischaracterization was just so obvious and plain, and how can anybody defend it? And they all do it. Every single professor I've ever seen describes the experiment incorrectly.
mischaracterizes the actual results and the actual doesn't draw what their math is doing, okay, and doesn't do math consistent with what they draw. They don't force the two to be consistent. And that doesn't bother you people? I mean, you know, I'm just saying, it's bad on you, right? I mean, shit. You're just demonstrating, like I said, the fact that this is so hard for you people to accept, and that you will be so obnoxious to this obvious truth, and you'll just keep denying it. I'm a tinfoil hat kook because I'm pointing out something so obvious as a mischaracterization, so obvious as a misdescription, and it's coming out of professors' mouths, people who are teaching physics, people who are supposed to be explaining how the theory works, and their explanation, if paid attention to and if detailed and if actually looked at, is completely incorrect. They're describing fishing, right, by throwing your lure into the desert sand. Okay, the water's that way. They're explaining it as, no, you throw your lure out there in the sand and you catch lots of fish. It's that bad. And I'm just trying to say, no, the water theory works. I mean, in the sense that the theory that you throw your line into the water where the fish are, the particle theory, works. The wavicle theory doesn't work. That doesn't fit. It doesn't make any sense. You can make understanding a photon is a composite object made of pieces, an object made of pieces, and that those pieces can be, you know, affected differently by interacting with matter, and that it is possible to reconstruct the pattern that the pieces had out of different pieces. One photon sends a piece there, and another photon sends a piece over there, another ray, and then one from over here they both end up going to the same place, and then they're in phase, and they can reconstruct the ray of light. That theory works fine. It hasn't been buried. It's not nailed in its coffin. None of that. And this is the kind of evidence they think they call this nail in the coffin evidence. Young proved. No, he didn't. Young didn't draw anything that makes that pattern. Young didn't have a theory that makes that pattern. Anyway. Maybe I'll just leave it at that. That's enough. So anyway, that's like I said, these are the type of questions I want to put to Baldy Katz and Friend, and see if they can give me some sort of, you know, what kind of bizarre excuses are they going to make? You know, I mean, I'm going to hopefully ask them to provide some material ahead of time. You know, show me a professor explaining that pattern correctly. You know, and show how he's doing it with wave math, not vector math from surfaces. Alright, anyway, so, yeah, that's enough. Till the next time, and such. So forth. Sorry about the background, but, you know, a little breezy.